Hi friends, in this video we are discussing line integral problems. Okay, before going to solve the problems, I will give one task for you. That is, evaluate integral x dy minus y dx around the circle x square plus y square is equal to 1. Here you observe, till now we are solved the problems like evaluate or work done, or else the problem in the form of f bar dot dr bar. So here directly they are given f bar dot dr bar directly. They are not separated like previously f bar and dr bar separately. So they are given directly f bar dot dr bar. Where we are discussing means around the circle. Circle is unit circle, that is. You see, circle is nothing but like this form or not here. So here the curve is closed curve. Till now we are discussed only for a straight line, or else y is equal to x square parabola, or y is equal to x cube, like, okay, that is nothing but we are discussed only simple and open curves, not a closed curves. But here we are discussing in a closed curve. Okay, now you have to solve this problem and you have to answer either A, B, C, D or E. Okay, now how to solve this one means you require basic knowledge. Now I am going to give that knowledge. Before going to solve the problems on circles or else closed curves, we have to learn some concept, basic concepts you have to remember. See, integral over C f bar dr bar, where C is a closed curve. Closed curve means that may be circle, that may be hyperbola, that may be square, or that may be rectangle. Okay, in this case it gives, that represents the integral over C f bar dot dr, it gives the amount by which the fluid tends to turn the circle by rotating around C. It represents fluid tends to turn the curve by rotating around C. Okay, now f bar dot dr bar means the result is here either vector or scalar, but here f bar is a vector and dr bar is a scalar vector. So dot product of the two vectors, f bar is a vector, dr bar is a vector. Dot product of the vector gives what? Scalar. Scalar means that may be the constant value may be is equal to 0, greater than 0 or less than 0. If the value is 0, then you can say f is irrotational. F is irrotational is nothing but the fluid no rotation, does not rotate. Okay, irrotational is nothing but does not rotate. For example, you see, if you take a fan, like roughly I am giving, this is if you consider I, this is J and this is K, I, J, K's are there. Now you turn, once you switch on the fan and after that turn off, then that may be I is falls on J, or else I may be becomes falls on K. In that case K falls on J. Okay, like if it is rotating will happen, if 1 falls on 2, 2 falls on 3. Okay, now if again 3 falls on 1, if at 1 if you are stopped, then there is no changes. If after turning same places, if it is came, the fan wings are reached same place, then there is no change, nothing but there is a no rotation. Okay, next, if it is greater than 0, fluid tends to rotate anti-clockwise direction. Next, if it is less than 0, then the fluid rotate clockwise direction, you can say. Suppose if it is equal to 0, there is no rotation, we will say. Okay, now we will solve the problems on the f dot dr around the closed curves. I am solving. If f bar is equal to minus 2x plus y times of I plus 3x plus 2y times of j, compute the circulation. Circulation is nothing but what? Indirectly closed curve. F bar about the circle C in the xy plane only they are given. So there is no z plane with a center at the origin and radius is 1. Radius is 1 is nothing but unit circle. Origin means here you can say simply the given is unit circle, x square plus y square is equal to 1. Like a previous problem, what you are doing, x square plus y square is equal to 1. Can you say like it is in the xy plane with a center at origin and radius is 1. Okay, but only here f dot dr they are changed. So this is f they are given here. Previously they are given f bar dot dr bar directly. Okay, now I will solve this problem. You try to solve this problem and give the answer. Okay, now my problem is, this is the problem. Given f bar is minus 2x plus y times of I plus 3x plus 2y times of j, and where the curve is, closed curve is x square plus y square is equal to 1. So we have to evaluate integral over c f bar dot dr bar na, that gives f1 dx plus f2 dy. Yes or no? This is in the xy plane. Obviously dz is not there. Okay, next integral, this is a closed curve c, here also closed curve c. f1 is nothing but minus 2x plus y times of dx plus 3x plus 2y times of dy. Okay, here you observe, now we have to evaluate this this integrand in the circle, unit circle x square plus y square is equal to 1. Here it is not like y is equal to x, y is equal to x square. If it is like in this form, then you can substitute directly, but here you have x square plus y square is equal to 1. So here also you can write y is in terms of x, means y is equal to under root of 1 minus x square you can write, but it will be lengthy process. So what I am doing means I am changing the variable here. In this case I am changing into parametric form. Parametric form is nothing but x and y are, we are changing into another variable t. So in this case I am considering x is equal to unit circle. Generally what we are taking means if x comma y, if you want to change into another coordinates, means that is polar coordinates, we are taking x is equal to r cos theta, y is equal to r sin theta. In this case you have a x comma y are in terms of r comma theta, but now I am changing x and y are in terms of theta. This is if you are changing a more than one variable in one variable, one independent variable, then you can say more than variables, one or more variables we are changing into one variable, then you can say this is a parametric form. If it is more than like x comma y are, we are changing into r comma theta is nothing but polar form. So are you understood here the difference between a parametric form and polar form? Okay, parametric form is represent only one curve, okay, independent of one variable here. So I am changing x is equal to cos t and theta, okay, theta t, which is not an issue. So y is equal to sin t. In this case in the unit circle, this is unit circle, so theta is from where to where? Theta is here total 360 degrees, from 0 to 360 is nothing but 2 pi you have to take. So the limits also we have to change, xy limits we have to change or not here. So theta is from 0 to 2 pi. Now x is equal to cos theta, y is equal to sin theta, we will substitute here. What about the dx? That also we have to change, dy also we have to change. So dx is equal to, okay, dx is here minus sin theta d theta, dy is equal to cos theta d theta. Friends, you have to understand one thing. Here you observe we are changing x terms are in terms of one variable t or theta. Okay, next y also we are changing into same variable, then only it is called parametric form. If you are changing x comma y are in terms of r comma theta, x is in terms of r and theta, y is also in terms of r and theta, and this is called a polar form. Okay, na? In the polar form, in this case you require r limit and theta limit, but in this case which limits are required? Only t limits. Here in this case we require only theta limits, because we are doing only line integral. If we are doing a double integral, in that case we have to go for the polar form. Okay, now anyway, now dx to dy values, x value, y values and theta limits you have to substitute in this equation, then it will becomes integral from 0 to 2 pi. Friends, you remember we are doing a closed circle. This problem we can also do by using a Green's theorem, because where C is a closed curve, closed curve. Okay, na? Due to that reason we can solve this problem by using Green's theorem also. Okay, we will discuss Green's theorem in the next videos. Okay, now limits of theta is from 0 to 2 pi. Okay, now what is this 2 times of x is what? Cos theta into cos theta plus y is sin theta into dx is minus sin theta d theta. Okay, plus 3x is cos theta plus 2y means sin theta into dy means cos theta d theta. So you have to simplify this now. It is very easy. Now theta is from 0 to 2 pi. Now multiply it side, d theta here also there, na? So total you take d theta outside, then this is, you can write 2 times of cos theta sin theta, plus into minus sin theta into sin theta sin square theta, d theta I am writing outside. Okay, plus 3 cos theta into cos theta, 3 cos square theta, Next, this is you can add plus into plus plus 2 sin theta cos theta. Okay, overall we have a d theta, right? Here you have 2 cos theta sin theta. So can you write 2 sin theta cos theta? Nothing but what? 2 sin theta cos theta is equal to sin 2 theta. Here also you have 2 sin theta cos theta. So this is also sin 2 theta. So overall you have 2 times of sin 2 theta. So limits from 0 to 2 pi to sin 2 theta. So I am separating the integral values here. So in this case we have minus integral 0 to 2 pi sin square theta plus 3 times of integral 0 to 2 pi cos square theta d theta. Here also you have a d theta. Sorry, here also we have d theta. Right. Now integral of sin 2 theta is minus cos 2 theta by 2. Limits from 0 to 2 pi. This is sin square theta is there. Na? So this one you can do in, of course, 1 minus cos 2 theta by 2 you can write. But you can also write this as 4 times of integral 0 to pi by 2 sin square theta plus this is 4 times you can add because it is the even function. Here also it is even function. 4 times of 3 is nothing but 12 times of integral 0 to pi by 2 cos square theta d theta. Wallis theorem we can apply. For that purpose only I am doing this. Okay. Now this 2 getting answer minus of cos 4 pi minus cos 0 minus 4 times of. This is how you can add. This is 1 by 2 pi by 2. Okay. Plus 12 times of. This is also 1 by 2 pi by 2. Now cos 4 pi. Cos 4 pi value is 1. Cos pi is equal to 0. Cos 4 pi is 0 only. Sorry, cos pi is 0 and this is minus 1. Now this 4 getting cancelled. Then you will have pi. 2 into 2, 4. 4 times of 3 is 12. So plus 3 pi. Finally you have here